All right, so this is just kind of a little introduction on how to use the phet circuit simulation instead of our normal setup, because we would normally be using physical things, okay? That sounds super vague. But we would normally be using actual physical objects. And we would most likely be using a compass to help us figure out what's happening inside of a circuit. All right, so we're kind of looking at this worksheet here, and I'm going to walk you through how to do this and how to use a compass to figure out things about electron flow. All right, so going back to our simulation here, we're going to be building a very simple setup. So we're going to have a battery, and we're going to have a light bulb, and then we're going to have some wires, and so we'll connect those. All right, Now, in the setup, I believe it has more than one battery, so if you want, we can put like 2 batteries in here. All right, so we can do that if we want. Now, normally, what you would discover during the experiment is that a compass deflects when you put it over a wire. So if you put it directly over a wire, you'll see all of a sudden, instead of pointing due north, it starts wobbling like 15 degrees or so. And so we talk about, why does it do that? And it ends up that there's this relationship between the flow of electrons and magnetism. And so since it's really just going to be an indicator of the direction of flow, then we're going to be using a ammeter. So we're just going to pull out the non-contact ammeter. The reason why we use the compass is because we like to simulate all the experiments that were done when people were first discovering this information. And when they were first looking into, what's going on with circuits, this was like the early 1900s. And everyone kind of had a compass because that's what they had on them. And literally one person just put the compass next to a wire and said, my compass is doing stuff. What's up with that? And so they use that to actually try and understand what's happening inside of a wire. Well, like I said, the simulation won't let us do that. So instead, we're just going to be using the ammeter. Okay, so here, when it asks, what is the compass deflection, it's basically looking for a numeric value. So here you can just write down what's the current. Okay, so is the current the same everywhere? Is it different in different places and things like that? The second thing it'll be asking you is the direction of flow. Hey, was it always deflecting to the right? Was it always deflecting to the left? Well, unfortunately here, we're just going to use the images. And so we can see that the electrons are always moving, and you can say either clockwise or counterclockwise. Because again, that direction, that deflection is kind of giving us an indicator of which way they're moving. To be perfectly honest, when they first did it, they didn't even know. And on top of that, when they finally guessed, they guessed wrong. And then they never changed it. That's why you'll see up here we have the conventional flow, because this is what they defined it as. So back in the days of yore, they defined the flow of an electron in the wrong way. Hey, Jim, cool. And so, game night, you got to play game night. And so they chose it as the way that a positive charge would move. But as we know, positive charge don't move. But they didn't know that at the time. And so they just said conventional current, and for some reason, we never changed our mind. So if you ever become an electrician and you ask an electrician what way the current goes, they're going to say this way, even though the electrons are actually flowing this way. All right. So you're going to be asked to talk about a compass. And whenever it talks about compass, like I said, you really just want to have the numeric value for the ammeter. That's your deflection value. And then either clockwise or counterclockwise, that will be the electron flow. And so you use that information to get the same results. You'll also be asked at some point to flip the battery, which is real easy. It's actually way easier than a physical space. So you just click on it, you can flip the battery, and you'll notice if you have 2 batteries against each other, nothing happens. So you'll have to flip both the batteries for it to work. And you might notice something different happens. Okay? So that's going to help out with your understanding of how to process all of these kind of little mini activities. And again, these are things that we would have done in class. We would probably do 2 a day. You do it with your group, but unfortunately, we don't have that option. So this is the best I can do. All right, so stay safe and keep enjoying science.